Hey, hi, I'm Nishanth Roy. This is CSYE 7270 midterm, and my topic is LLM-driven NPC dialogue versus behavior trees in Unity. My claim is this: like a developer will understand LLM-driven NPC dialogue well enough to decide when to use it versus the behavior tree, without shipping a game that freezes on NPC responses or break it to narrative consistencies. Consistencies. Here's the pipeline I'm arguing for. Here's the diagram that we can see on the screen. Three layers. Play input hits the behavior tree first and then to LLM. Under 1 millisecond, domestic no network call. If it quest critical, the BT handles it to the LLM, and the LLM never sees it. So if it's low strikes flavor, it passes to the LLM with a constant prompt. If the LLM times out of feedback line fires automatically. Here we can see the failure mode I'm addressing must, like, most developers skip the BT entirely and send everything straight to the LLM. That causes three things. One is hallucination, non-determinism, and latency. My essay proves this is an architectural mistake, not a model mistake. And then we'll see the notebook. Here it is. Okay, let me open it. Okay, here's the configuration cell. Here we can see this. Yeah, this is the one. Okay, uh, let me go through it. Here, let's set it to true first. Okay, alright, okay, and run this and then see, here the use hybrid architecture is true. Is like this is correct architecture, and then I asked the cellular key three times. Here we can see this. Yeah, here we can see I asked it three times, and then we'll see like how it goes. Same answer, like, yeah, let's run. When it was false, that's when I ran it, and now it's true. We can see here, yeah, same answer every time. Same answer every time. Source behavior tree latency under 1 millisecond, dramatic s. Yeah, all it's same all the time. The BT caught the quiz critical and then handle it without touching the LLM. And then test 2 and test 3, here we can see low stakes inputs reach the LLM. The 1.5 second false back fires, plays never sees a freeze. Now let's go and change it to false and see. Okay, okay. See, was there? Yeah. Now I'm triggering the failure. One variable like false. Sometimes test one raw LLM like determines takes no, and then quiz critical dialog is now hitting the model without zero constraints on a live API. This returns different answers every run. Your quest tech breaks. You cannot reproduce the bug reliably. Like, yeah. Then we'll see again. Yeah, here we are. So I want to stop here. This is my human decision node. The AI proposed routing all inputs through a simple keyword filter. If the word says key, if the word is key appears, return a canned response. I rejected that. A keyword filter is not behavior tree. It doesn't handle component intents. It doesn't scale enough, and then it would have misrepresented the entire argument of the essay. My decision was to implement a proper intent classification function with exploit return, none passing through the LLM layer. That distinct is the whole point of the piece. And yeah, the modification that breaks the system, changing the use hybrid architecture to false. That then we run the cell here, and the cell the like the number of, yeah, this seventh cell. Yeah, here we can see, like, see the domestic no on every critical response. Then when we change it to true, as we saw again, we'll see here again. uh, Okay, here we go. Yeah. So it's fixed. The model is identical in both runs. The architecture is everything. The course master claim more. It's made executable. The open question I didn't fully resolve. What happens when the approved facts list grow to 500 entries? At some point, prompt injection becomes a real risk, and the constraint levels need to move out of the prompt and into a retrieval system. That's the next piece we will see. Yeah, here we go. Yeah, thank you.